This is CCNA. I'm Ryan. We're here for part 4 of the Troubleshooting Enterprise Networks. We've got some tuning to do. So what they want us to do is make sure that we use this path right here. We've got some fiber optic, gigabit Ethernet goodness going on. And only use this serial connection in some sort of event where one of these paths gets cut. So we're going to test it out. Let's just confirm where the traffic's going. That's what they want us to do here in the first step with the trace route. Trace. Oh. There you go. And it's 92.168.20.254. So we're going to this TFTP server over here. So to get there, we have to go through router 2, but do we go through router 3, which is the preferred path? Or do we try to shove it through this serial link because we haven't accounted for the bandwidth? But look at it. It says that our first network that we go to is 10.1.1, and that's this network right here. Well, it's 10.1.1.0. It's the network. Then we're going through the number 2 host on there. Anyways, we don't want to go that way. So we need to tune the router. If we do a do a show run, and we look at interfaces here, you see that yes, we have increased the cost for the serial link, but we've done the same for the gigabit Ethernet link. So perhaps this configuration used to be for a serial link, and we just copied and pasted it and didn't think too much about the cost. But we need to lower the cost. And if we do that, then OSPF will prefer this route. We can also see this if we do show IP route, that the serial 010 shows up there in the routing table a lot. So we know OSPF is sending traffic there. It's telling us that's what it plans to do. We want to change those plans. So we're going to go into global configuration. Change an interface to. Well, one interface in this case. We're just going to do no IP OSPF cost, and that should do it. We can put the number in there too, but it's extra typing stuff, and the putting that much of the command in there, it knows to take it out. So if we save it, then we look at the routing table again. Okay, if we're going to, the only time the serial is in there now is if we're going to that network. So that's fine. That's what we want. But notice that any other instance of serial, and notice we had some other ones in there like that, are gone. So we're now successfully routing our packets in that direction. But if we look here, again, router 3, show IP route. We're still sending traffic across 010. See. Oh, wait. That's to the 10 network. Okay, so that one should definitely be there. Actually, okay. Also directly connected. Actually, I don't see anything wrong right now. And in fact, increasing that cost makes it so that we definitely will not send traffic in this direction unless it's um, beneficial. But we also don't want to make sure that this cost doesn't go down to where that path is more efficient. So even though we're well, actually, did we actually get some in there? No. Even though we're not routing packets that don't need to go in that direction right now, if we look at the show run, let's do that. We should still make sure that we've 0, 1, 0. There it is. We should still make the cost match the bandwidth. Where is it? Yeah. So it's there, but it's not. No, the other one. So maybe that got replaced. So we're going to G0, 1, 0. Yeah. No IP OSPF cost. We're done. Notice we're at 87%. It's a good sign. Okay. Copy. There we go. And then if we, I mean, this one doesn't change the routing table, but it's just for consistency. If we had a bigger network, it might make a difference. And oh yeah, copy run start. Just remember, we don't have to do this in Packet Tracer, but in real life, it can be tragic. Put all this work into changing the configuration, and then someone power cycles it, and you lose your configuration. If you have a good system for automatically backing up the running configurations, though, then it wouldn't be such a big deal. You just download the configuration somewhere else. Trace route command. For R1, where the path actually changed, you can see it now. We're going that way, which seems longer because there's more hops, but the bandwidth is greater, so it should be higher performance. Okay, and now what we're looking at is NAT, and NAT's happening here on router 2. What we can do is it wants us to take down this interface here, so we'll shut that down. Interface G0 to 20 shut. It's down. Okay. Now we have to go this way to get to there. And wants us to take us from router 1 to router what? No. It wants us to ping from router 1 and router 2 to this outside host. So we'll just do that. Remember to do it a couple times because it likes to pretend like it's actually doing ARP to get addresses, and we're failing horribly. And we're going to figure out why in just a minute. We'll do another one just to be sure. Okay, No. Damn it, it's not working. What are we going to need to do? Well, it tells us exactly what we need to do. We need to look at NAT, which might not have been your first choice. Show IP NAT translations, and there's nothing happening. Not a good sign. Especially since to get to that outside host, we would need to do some NAT translation. So if we're not translating the address, it's not going to be able to send those private IP addresses across the public internet. Okay. So, and if we do the show IPNAT statistics, it'll validate what we just thought. Why is there no misses? There should be at least a couple misses. Okay, let's do the pings again. Okay. Let's see if that was enough to get us a miss. No. All right. Well, we're not showing any hits or any misses. And I don't know exactly why we're not seeing any misses, but it's obviously not working. Maybe if we type the ping, it just likes to ignore the ones that we don't have to type in. So what we're trying to do is get this thing to register a miss. And translating from private IP addresses that we have into a public one. And it still might not. One more time. Pick another. Yeah. Okay. So it's not even getting into the NAT. It's forwarding the packets, but the packets aren't going across they're getting to here that we're dutifully sending them out, and then they're getting filtered out. The ISP isn't going to transport the private IP addresses for us. Okay. But we want there to be hits, and there's none. So I'm not sure if we do show around next, but we can, because that'll work. There is what we're doing. We're overloading our gigabit Ethernet 00 interface. We need to look at this list NAT. There it is. We're permitting the right addresses. The 10 and the 192.168 network. However, if we look at, where'd our interface go? Yeah, we just pass it on by, that's all. If we look at the serial interface, it's not designated as an inside interface. So it tells us right here what we had to do anyways. We didn't have to look at that. Conf T interface serial 0/0/0. And we want to do IP NAT inside. So what we're saying is that this is the inside network. We want you to have this participate in NAT. Nice. Okay. Now, drum roll. Successful. They didn't even have to do it twice. Go from here to here. Successful. So we're translating it. The internet ISP isn't stopping us anymore. We're at 93. So I think I might have skipped changing a what do you call it? Native VLAN on one of these. According to the address table, every device should be able to ping every other device. PC4 should be able to ping the TFTP server, and outside host is using IPv6. So, just because, for thoroughness, let's check the results and see what I missed. Yeah. So, so if we look at router 3, it's router 3 here. We want these networks to get advertised, but there's no other routers on any of these networks, so we don't need to send OSPF packets out here. So what we wanted to do is come in here and do IP OSPF router. Oh, sorry, that's show command router. OSPF1 and let's just do IP, do show IP interface brief. All right, so for these interfaces here, we want them to be passive. So we do passive interface, G0 slide. And we have to do the whole sub interface, right? At least I think we do. $30, about 30 and 40. Doing the up arrow here. And 50. Are we going up to 100? Yeah. So we hit it. We nailed it. All right. It might have told us to do that earlier, but I skipped it. All right. So yeah, we know that we're done, but why not? Oops. Why not do a verification really quick? So we go to PC4. PC4 to the command prompt. There we go. Ping TFTP server. Is that what I wanted us to ping? DB8 and B20. So we go to network portion. Then we put in host portion 254. And no, it doesn't like it. We get it right. B. DBA 50. Huh. So it says that we can't reach there. So somehow we completed it, but we missed something. PC4 should be able to ping TFTP server and the outside host using IPv6, but no, we can't. Ooh, a mystery. A mystery. Look at the desktop here real quick. Okay, so our guy here. Oh, we didn't turn on the interface again. It told us to do that, didn't it? and I skipped that step. Should just be able to arrow this. There you go. All right, we're back on. Though we still had a path to there. So there's something going on with the OSPF that it's not quite right. And command prompt. Oh, it still didn't like it. Okay. Why? Oh, we hadn't loaded. Oh my gosh. OSPF is still running. So now if we look, we do show IP OSPF neighbor. There we go. Now we're talking IPv6. OSPF neighbor. That's what we wanted. Yeah, apparently we were only doing it with one neighbor. And we're only doing it there. I don't know why these guys aren't doing OSPF for most IPv6. But we're not required to set that up, though you would. I mean, I don't see why you wouldn't. Maybe they had some real weird reason why they didn't want to do that. But now, meh. Now we can get there. So, there we go. So, maybe they did it on purpose so that you remember to turn that back on. Again, I probably just skipped that step. Apparently it doesn't affect your completion rate, though. So, yeah, we've already done some pinging inside of these guys, and those worked. And the addressing table's up here. So, we can confirm those guys. Remember, the main thing that we did was, they don't even give us what the default route was supposed to be anyways. Great. So if we were looking at the troubleshooting steps, and this one, we would be just doing like the analyzing. We do the gathering information, the analyzing, and then the testing the hypothesis in here. Eventually, you'd want to document all this and say how you're configured. Maybe do a separate one for OSPF and a separate one for NAT, and then say how the whole network is set up. Be a good way to do it. So that's it. That concludes troubleshooting enterprise networks. Good luck.